Hey guys, welcome back to another Brainstellar Quant puzzle. Today we're doing the problem, the plane in the wind. This is an easy problem. Let you guys go over it. So basically, there's two airports, airport A and airport B, and the plane travels in a straight line from airport A to airport B, and then back to airport A. And well, considering there's no wind, it travels with a constant engine speed, right? Which basically means that it travels with a constant speed v, let's say, or ve, back and forth. So let's say the distance between A and B were to be d. So the time is basically two times because it goes back and forth. Uh, the distance upon the velocity of the engine. So this is the current total time it takes, right, for the entire trip. Now it's asked if, let's say, there's an additional velocity, the velocity due to a constant wind. So let's call this VW that blows from A to B. Now in this case, what will be the total time taken? So I mean, intuitively, you might think that it could be less, it could be greater. You can't really tell, but with a bit of math, you can really see that it's always going to be a particular case. So the time, well, the velocity while going from A to B now becomes VE plus VW, and the velocity while coming back becomes VE minus VW. So the time becomes d upon VE plus VW plus d upon VE minus VW. So I've simplified this a bit. So by looking at this fraction, we can see that if VW were to be 0, we would basically get this case. And for VW, anything above 0, the denominator gets smaller, which means the entire fraction gets bigger, which means the time gets bigger. Right. So actually, for any velocity of the wind greater than 0, the total time it will take to travel becomes larger. There's also a few other ways to come to this same conclusion. Well, for example, if we were to consider VW equal to the velocity of the engine, then while going from A to B, the time would be halved because we're now twice as fast. But while coming back from B to A, our effective velocity would be 0. So basically, it would take us an infinite amount of time during the second trip. So that's one way you can start to approach towards the answer. Another way is to just say that during A to B, we have sped up our velocity, but the time decreases. So the time duration during which our velocity is sped up is much less because while coming back from B to A is when our velocity decreases and our time increases. So the time duration while our velocity is sped down is a lot more than the time duration during which the velocity is increased. This is not a very proper solution, but it starts to develop an intuition. And this is basically a summary of my explanation. This is a summary given at the Brainstellar website. Thank you.